In lighting, there are 5 descriptions or terms that we use, metrics we call them, to describe the light. And I'm going to demonstrate them for you now. If you take a look at the candle, this is our original light source. The candle is actually emitting an intensity in all directions. And that intensity is actually 1 candela, which is about the amount of light you get from a candle in any and all directions. This unit of intensity is used actually to describe the light output from any light source. So I take a light source like my flashlight, I aim it at you, you see a much greater intensity compared to the candle than as I vary the angle at which you see it. So this is basically the beginnings of a simple photometric test in trying to describe the light output from any light source, in this case a simple flashlight. The second unit of measure is flux, which is the light which flows in air. To talk about that, I'm going to use this frame. This frame is carefully chosen to be 1 square foot, and I'm holding it 1 foot from my source with an intensity of 1 candela in all directions. In this definition, what I have is 1 lumen of light flowing through this window. And that's the flux of energy flowing from this source. Now, it's not hard to imagine that there are other frames out of which this light can flow. In fact, there would be 12.57 lumens of light being emitted equally from a source of 1 candela intensity, 12.57 lumens of flux or light flow. So we talked about flux being the unit of measure for the flow of light, and my question to you is, does light flow? So the answer is the light flows from this source of light through this frame. You see the shadow in the wall. You see when I move the frame, the shadow also moves. This tells us that in fact light as a form of energy does flow. The question, at what speed does it flow? At the speed of light, of course. The third unit is illuminance, which is the density of light that falls upon a surface. When I consider a surface instead of a window that is 1 square foot, and I have a source with intensity of 1 candela, in fact I have 1 lumen of light falling upon the card. The density of light on this surface is a foot candle, 1 lumen per square foot. Why do we talk about foot candles? It's because foot candles are actually cheaply and inexpensively measured. So with a simple device like a light meter, I can measure the density of light falling upon a surface. So if what we said is true about foot candles, using our light meter and a flashlight, if I hold the flashlight a certain distance from the light meter, I get 1 reading, but as I vary the distance from the meter, the numbers slowly decrease as a function of the distance, reducing the density of light on the foot candle meter. Same too with angle. If I start at a certain angle and I try to keep the distance the same but vary the angle, the numbers also go down. So we understand that foot candles, or the density of light, varies as a function both of distance and also of angle of incidence of light. These 2 things are accounted for in both the equations that we use for determining illuminance. There are 2 things that impact that density of light, and I can demonstrate them going back to my flashlight and looking at the wall. If we consider a circle on the wall, there's a certain density of light falling on the surface, the illuminance. As I increase the distance, you see that the light is actually covering a much larger area. Therefore, the density of illuminance, the foot candles, are being reduced as I increase the distance. This is called the inverse square law because it varies inversely to the square of the distance. It also varies, however, with the angle at which the light hits that surface. And you see that as I increase the angle, the light is covering a much greater area. And looking at the very center point, I can practically project that across the entire wall. The density of that light, therefore, is greatly reduced as a function of the cosine of that angle. We'll revisit this when we talk about calculations. The 5th way of talking about light is the light which comes off of surfaces. And let's consider our card again. 1 square foot, 1 lumen of light falling upon 1 square foot or 1 foot candle. Now let's talk about the light coming off of this surface. That would be a function of the reflectance of that surface. Looking at a white surface, we have certainly more light coming off of this surface from our candle compared to this surface, which is in fact black. The only difference between the 2 surfaces are the reflectances, and this is referred to as the excitance. How much light is coming off of this surface, or the density of that light coming off of a surface. It's largely a function of illuminance times the reflectance, and that's what excitance is. But that's not the end of the story. because when I change the surface again to one which has a different reflecting characteristics, I get quite a different effect. So even though perhaps this card is 95% reflective, and perhaps this surface is also 95% reflective, a mirror. So the total amount of light or the extants coming off these surfaces are the same, but the way in which light comes off of these surfaces is very, very different. And this is a function of the specularity of the surface. And this is what we call luminance, the specific way in which light comes off of a surface. It's luminance which allows us to see things. It's the luminance which enables our ability to see the world. And it's luminance that we really try to control as we design light in architectural space.